Good morning, children. Nice to meet you all again from the physics lab. Today I'm going to perform some experiments based on upthrust. Okay, that I explained you in the previous video. I'm going to perform some experiments. Okay, so in page 106, we have done till factors affecting upthrust, right? Formula of upthrust, then followed by factors affecting upthrust. Okay, what is the formula of upthrust? Let's quickly recollect it. Upthrust is equal to, upthrust is generally represented as FB, buoyant force, FB, okay, is equal to volume of solid into density of liquid into acceleration due to gravity. This is the formula for upthrust. Formula for upthrust. Okay. Now, the next heading that we are going to see is effect of upthrust. In page 106 on the right side you have effect of upthrust. What does upthrust do practically? You would have all observed it. If you're while taking bath, maybe you're taking out a mug of water. As long as the mug is inside water, you'll be feeling light. The moment you take it out of water, you'll feel that it is little more heavier than what it was. Okay, if you would have the experience of drawing water from well, there also it's a nice experience. As long as the bucket is inside water, it'll feel as if, okay, it'll be very easy to draw the water up. Okay, as long as the bucket comes out of water, then you have to apply more effort, because inside water it was weighing less. Inside water it was weighing less than outside water, and that is due to upthrust. Okay, that is due to upthrust. Now, why does it weigh less inside water? Now, when this body is inside water, now I'll be using few terms. This is weight in air. W air means weight in air. Okay, and then this is W liquid, weight in liquid. Okay, W liquid means weight of the body in liquid. It will be different, and this difference is because of upthrust. Inside water, the upthrust is, outside water also here there is upthrust due to air, but that is very less, because density of air is very less. Upthrust due to air is very less. So if I hang a body here, so its weight, what you measure will be its entire weight. Okay, but when I put it inside, two forces are acting. Weight is acting down and upthrust is acting upward. So the weight, the resultant weight that when I put a spring balance and I try to measure, the resultant weight will be W minus upthrust. Weight in air minus upthrust is what will come as weight in liquid. Hope you all understood it. Okay, the first thing you should know is, because of upthrust, a body will weigh less inside water. Okay, this I am going to show you practically. Okay, this is a known mass. Okay, each disc is 50 grams, so it's 100 gram. Totally it's 100 gram. Okay, so this is the spring balance. Okay, hope you all have seen it before, and I have to hang the body whose weight has to be found from here, and there will be readings. Okay, there will be graduations here that I have to find. Okay, now when I hang like this is called weight in air. Okay, weight of the body in air, and it comes out to be okay, 100 gram. Okay, weight is 100 gram. If you can see it, I don't know whether you can see it. So weight is 100 gram. It's showing here. So its weight is 100 gram. So weight in air is 100 gram. Now, I'm immersing this in water. Okay, this is a beaker with water. I'm immersing it in water. Okay, and when I immerse it in water, you know what the weight is? Somewhere, I think it's 90 gram force. It's 90 gram force. We use the unit gram force because this is weight. It's not mass, it's weight. So weight in air, when I weighed it outside, it is showing 100 gram force. But when I put it inside water, its weight decreased and it's only showing 90 gram force. Are you able to understand? This is the effect of upthrust. Whenever a body is immersed inside water, it will weigh less than its original weight. It will weigh less than its original weight. So, this upthrust will be equal to weight in air minus weight in liquid. Here I have taken water. I can take any liquid. Okay. So 100 gram force minus 90 gram force, 10 gram force is the upthrust. So the upthrust exerted by water on this body is 10 gram force. Have you understood, children? This is the effect of upthrust. Practically, a body will weigh less inside a liquid and that difference will be upthrust. Okay. As I explained you here, why does it weigh less inside water? There is this upthrust. So when I take the resultant, it will be W minus FB. Okay. So, I think you can mark it in your book. Page 106, effect of upthrust is that weight of a body immersed in a liquid appears to be less than its actual weight till this point. And then they are given some examples. Lifting of a bucket full of water from a well. As I told you, okay, you are filling water and as long as it was inside water, it will appear light. Okay, easy to pull the bucket as long as it is inside water. But as soon as it starts coming out of the water surface, it appears to become heavy and now more force is needed to lift it up. Okay. Then there can be a reasoning question possible. When pulling a fish out of water, it appears lighter inside water as compared to when it is out of water. Same thing, inside water there was upthrust, so its weight is less. Another possible is reasoning question is, a body weighed by a sensitive spring balance will weigh slightly less in air than in vacuum. Okay, when you compare air with vacuum, vacuum will not exert any upthrust. Air will at least exert some upthrust, but vacuum will not exert any upthrust. Okay, so definitely a body will weigh little more in air than in vacuum. Okay, this is the first thing I wanted to explain you. And another thing, this weight inside liquid, it's also called apparent weight. Apparent weight. In the sense, apparent, you understand, it's not real. Something it's not real. Its actual weight is 100 gram force, but when I put it inside water, it appears to weigh 90 gram force. It appears to weigh 90 gram force. So that's called its apparent weight. Apparent weight. Okay. So don't forget, the apparent weight will be the weight inside liquid. So I can weight inside liquid, that will be, I can write a formula like this: weight in air minus upthrust. Weight in air minus upthrust is weight in liquid. Okay, weight in air is 100 gram force, upthrust was 10, 100 minus 10 gives me 90. That is the apparent weight of this body. Okay, now we go to the next one. Archimedes principle. Okay, the next topic is Archimedes principle. So Archimedes is the name of a scientist. He gave this principle called Archimedes principle. Now, before going into the principle, how they got this principle, we should know. Now, upthrust is equal to the formula for upthrust, volume of solid into density of liquid into acceleration due to gravity. Now, one more thing you should understand. Suppose I immerse any liquid inside water. I immerse any solid inside liquid. What happens? It will displace some water. Yeah, it will displace means the level of water in the tube will definitely rise. It was 850 before, now it's 860. Okay, so now this increase in volume will be equal to the volume of the solid, or I can say instead of volume of solid I can write volume of liquid displaced. Liquid displaced. Liquid displaced means how much has the liquid height increased from the original one. Displaced means how much has it shifted from the original one, how much has it risen. Okay, so volume of solid will be equal to volume of liquid displaced into density of liquid into acceleration due to gravity. Now, volume of liquid into density of liquid, you know that density is mass upon volume. So density into volume will be mass. So volume of liquid displaced into density of liquid displaced will be mass of liquid displaced. Mass of liquid displaced. I am not writing mass of liquid. I am not talking about the entire mass. I am only talking about the mass of liquid displaced means by how much did the level of water rise into G. Mass of liquid displaced into G will be nothing but weight of liquid displaced. You know, M into G is weight. So, weight of liquid displaced. So, upthrust is equal to, so this is what Archimedes principle says. According to Archimedes principle, whenever a body is immersed in water partially or completely, it experiences an upthrust which will be equal to the weight of the liquid displaced by it. Just try to understand. Weight of the liquid displaced by it. So it will displace some liquid, that will be its volume. If I multiply that with density, that will give me the mass. If I multiply that with G, it will give me the weight of liquid displaced. Okay, so this is Archimedes principle. Okay, so the statement is given here, you can underline. Archimedes principle states that when a body is immersed partially or completely in a liquid, it experiences an upthrust which is equal to the weight of the liquid displaced. Okay, three parts are there. When a body is immersed partially or completely in a liquid, that's the first point. It experiences an upthrust is the second thing. And the third point, which is equal to the weight of the liquid displaced by it. It's important to write displaced by it. Now, we are going to do I'm going to show you practical experimental verification of Archimedes principle. Okay, so this is this is how the conclusion came of Archimedes principle. Now we are going to prove or verify Archimedes principle. So according to Archimedes principle, so upthrust should be equal to weight of the liquid displaced. Two things we have to find, upthrust and then weight of the liquid displaced, and then both should come to be equal. Okay, I am taking this as the solid. Okay, it's because I wanted something of more volume. It has to displace more liquid. So I took this bottle with some stones inside, and the weight of this is 180 gram force. Okay, weight in air is 180 gram force. Okay, so to find upthrust, I need what? Weight in air minus weight in water. Liquid here is water. So my weight in air is 180. Yeah, 180 gram force. 180 gram force minus, we have to find its weight inside water. Weight inside water. So, weight in air, it's 190 children. Okay, I checked it again. It's 190. Okay, it's 190 gram force. 190 gram force. Now, I'm going to insert this, okay, inside water. And find its weight. Okay, I'm making it fully submerged inside water. I hope you're able to see. So I made it fully submerged inside water, and now its weight is 10 gram force. Okay, when I fully submerged it in water, can you see the weight is much more here? When I took it outside, when it was in air, its weight was here, 190. When I put it in water, its weight is only 10 gram force. 10 gram force. Is it clear? So, the weight in water is 10 gram force. So, 190 minus 10, 180 gram force is the upthrust. The upthrust exerted is 180 gram force. Why is it so much when compared to this one? Because the volume of this body is more when compared to this. That's why its upthrust is also more. Okay, this when we found upthrust came out to be some 10 gram force or something. But here upthrust is more because the volume is more. Okay, so 180 gram force. Next I have to find weight of the liquid displaced. Weight of liquid displaced. Now before finding weight, first I can find volume of liquid displaced. Volume of liquid displaced. How do I find that? Now before putting the solid inside this, the water level is showing 750 ml. Okay, 750 ml. Not liquid is, 750 was its original volume. And when I put this inside, $930. Okay, the level of water, when I put it inside, the level of water that is shown here is 930. Okay, so 930 minus 750. Are you able to see, children? What was the volume when I immersed it inside water? That volume minus the volume before that. Without immersing it, what was the volume? That much is the volume of the liquid displaced by this solid. When I put this inside the solid, it has displaced how much? This much. That is, okay, this is 180 gram force. Sorry, 180 centimeter cubed. 180 milliliter or 180 centimeter cubed. So volume of liquid displaced is 180 centimeter cubed. You know that density of water, density of water is 1 gram per centimeter cube. 1 gram per centimeter cube. So we know the formula. I need the mass of liquid displaced. Wait, basically I have to first find mass of liquid displaced. Now mass of liquid displaced will be, so I have to find mass of liquid displaced. That will be density is mass upon volume. So mass is density into volume. So anyway, so mass of liquid displaced will be, volume is 180 into density is 1. So 180 gram. 180 gram. And the weight of liquid displaced will be 180 gram force. 180 gram force, and that is the same as the thrust. Hence Archimedes principle has been verified here. Upthrust is equal to the weight of the liquid displaced. Now how did I find the weight of the liquid displaced? First I found the volume of liquid displaced, then I multiplied it with the density of water, that is the liquid here I have taken. That gave me the mass of liquid displaced, and that I converted into weight by putting gram force here. That gives me the weight of the liquid displaced, and I am able to prove that weight upthrust is equal to the weight of the liquid displaced. So this is how Archimedes principle is being verified. So once again I'll say the statement of Archimedes principle. Whenever a body is submerged, immersed partially or completely in a liquid, okay, it's not water, it is liquid, it can be any liquid, it experiences an upthrust which is equal to the weight of the liquid displaced by it. I hope you understood it. So children, in the book, let's quickly mark it. So till this I think we did in the previous in the video, and this is how that little derivation they did, and conclusion was upthrust is equal to weight of the liquid displaced by the submerged part. That is the statement of Archimedes principle. As I told you, it should have three parts. When a body is immersed partially or completely in liquid, it experiences an upthrust, and the third part equal to the weight of the liquid displaced. Then effect of upthrust. Okay, and what is the effect of upthrust? The effect of upthrust is that the weight of a body immersed in a liquid appears to be less than its actual weight. So two possible reasoning questions. While lifting a bucket from a well, it appears lighter as long as it was inside water, then it becomes heavier. Then while pulling a fish out of water, it appears lighter. So for both the things, the reason will be the same thing, effect of upthrust. I want you to underline one thing here. Volume of liquid displaced by a body is equal to the volume of the submerged part of the body. Okay, that's one concept you have to remember. When I submerge this inside water, it will displace liquid equal to its own volume. Okay, the level of water will rise by the volume of this. Okay, whatever is the rise in level of water, that is the volume of that. Okay, statement is over. Then we have experimental verification of Archimedes principle. Actually this we'll be doing in practical, and but I just wanted you to understand it. So okay, I think you have already written it. And okay, with this solid bodies with density greater than density of liquid sink, and density less than density of what liquid float. Okay, so this I'm not doing here because C part separately we have a chapter called flotation. There we'll be doing in detail. Okay, so with this A part gets over. We'll be doing the numericals during Zoom class. Thank you, children.